Hello everyone. This is lecture 170. You are most welcome. I have taken a topic fixed beam and propped cantilever of non-uniform section. If you get this type of problem, if there is some force which is applied at C, right? Yeah, it can be a force applied somewhere else. It is not in center. Maybe. First of all, we are taking a load 24 kilonewtons working at point C, which is the middle part of this beam AB, and the section of this beam is non-uniform. It is up to 4 meter 2I and rest 4 meter is RE. So how will approach to find out the moment at A and at B? So for this we have to go for some idea how this can be evaluated, how it can be solved. So first up you see, we have in the Porter frame, we have studied the sway conditions. There is a horizontal force which is pushing from left to right, making some sway, that is deflection, and according to that we are getting, you see this is something like that. If it is pushing in this way, that is right hand side, then we are getting negative moment at the edges like this. So what will happen if this beam A and B at point C, if we adopt AC and BC as a propped cantilever. As a propped cantilever means the force is upward from here or downward. This is prop. This point has been propped. This is swinging something like that. So this is producing some sway. So how this sway is produced, it depends on the end conditions, for which we have got this equation. I1 L1 square is to I2 L2 square. That is the moment which will be produced will be 2:1. If here is 2, then here at B will be in the ratio of 2:1. So we can have this distribution factor by taking this joint C, CA and CB, and this is 2I/4 because it's fixed. We are taking this fixed. This is intermediate, but it is fixed. 3I/4 total. 2/3 and 1/3 we are getting this. Okay. So what will happen? We can proceed with the assumption that there is some sway which we don't know, but we know the relation between this CA, that is AC, and BC moment. So if you go for this, you will find, for this you can draw, this is your A, this is your B point, this is your, suppose this is your C point. So what is there? We have got this type of thing. So the relation is 2:1. So what will be here? If you take 6, this will be 3. Okay, 2:1. So we are taking 6 minus 6, it will be, this is also minus 6, this will be plus 3.0 and this will be plus 0.30. The concept is this, that if left hand side is up with droop, then this moment at A and C, that is MAC and CA, will be taken negative, and if the B is up right hand side and droop is left behind back, then this will be taken as positive. So we have adopted this thing. So we'll go for this thing. We are just assuming some moment, and for that moment we try to calculate the sway. That is sway, vertical sway, for which this moment we are getting this moment, for which we are getting the moment. So let us solve this problem. So this is minus 6 plus 3 means this is okay. This is 3. So the distribution will be 1/3, that is plus 2 and plus 1. Okay, plus 2 and plus 1. Because 2/3 of 3, the unbalanced moment is minus 3. So this will be taken plus 3 ka 2 by third. We are 2 by third of 3, 2 and 2, 1 by third of 3 is 1. So we are getting, we try a line in this way. So this moment will transfer here 1.0. Okay. And this will be transferred here 0.50. So final moment, what will be final moment? This is minus 5.0. This is minus 4.0. This is plus 4.0. And what will be this? 3.50. This is your final moment, which we are getting. What you will next step, what you will do? Let us see what will happen to the beam. The beam is in this way. This is one part. This is another part. So this is some prop is there. Suppose the reaction is somewhere, reaction is there. So there is a moment. We are taking part A to C. A to C. We are taking A to C. What is there? There is a moment 5. This is anti-clockwise. Anti-clockwise, this is 5.0. And what is this? This is also anti-clockwise at this. This is 4.0. If this is your BV and this is your BA, what will happen? You can calculate always B and BB. So if you calculate the BA with respect to this thing, you can calculate BA with respect to this. So BA into 4, this is going in this way. Opposite of this equals to 5 plus 4. So BA equals to how much? 9 by 4. 2.5. This is 9 by 4. 9 by 4 means 9 by 4. This is coming how much? This is 9 by 4. This is coming 2.25. This is coming 2.25. So this is 2.25. And what about this BB? BB equals to minus 2.25 because there is no load in this configuration. So we are getting sway. This is your sway. This sway is downward. This is sway is a downward. This is 2.25 is sway is created because of this moment. So this is the moment which we are getting this 2.25 we are getting sway. This is 8 point. This is 2.25 because of this thing. And what will be the next sway because of the B? So you can go like this. You can go like this. This is your B. So this is your VB, right? And what is this is 3.50. 3.50 positive. So this is your 3.50. And what is this? This is a 4. It is this point is 4. 4 is also in the clockwise direction. This is clockwise direction. So what will be happen to BB? BB into 4 equals to, this is your opposite direction. This will be also 4 plus 3.50. So your BB equal to how much? 7.50 divided by 4. So how much we are getting? Let us see. This is 7.5 divided by 4. 1.875. So we are getting again 1.875. Then sway will be how much? This will be this will be also 1.875. So this one sway and this is another. तो टोटल स्वे क्या होगा? टोटल स्वे क्या होगा? That is your BB का दोनों का, that is 2.25 plus 1.875. दोनों आप जोड़ लोगे. You have to add both of this plus 2.25. This is 4.125. This is 4.125, right? Okay, this is this much of load. This much of load is coming here to produce this much of moment at edges A and B. This is okay. So what is the procedure to follow? That if the end condition is like this, we have I1 L1 square to I2 L square, which is responsive to produce some sway. Then ratio, according to ratio, we have to put these values and we go for the distribution of moment according to the distribution factor. Finally, we will get the moment. With the help of this moment, what we'll do, we'll find out the BA and BB. The BA and BB, the summation of BB is upward, then the summation will produce you total sway. So this is your sway. Okay, this is your show. That is 4.125. Now let us find out the final moment which will carry this beam. Now these moments are because of the force of 4.125 and but this load is 24. So your sway will be, your moment, final moment will be 24 divided by 4.125 multiplied by this column A. So we'll write here the final moment according to this. So you put it like this. So let us see. This is 24 divided by 4.125, which is this much, multiplied by 5. This is this much, 29.09. This is coming 29 minus 29.09. And what is this? Divided by 5, multiplied by 4, 23.27. This is minus 23.27. This is plus 23.27. And what about this? 3.5. 20.36. This is 20.36. This is plus 20.36. This is plus. So these are the moments. These are the final moments, which is gained by multiplying this. This is final moment. This is final moment. ये आपके final moment हो गए. This is your final. Try to understand. These are the final moments. What will next we'll do? We'll try to find out the final these reactions. So let us produce to find out the final reactions. So as we have done previously, we'll go for this thing. We are taking A to C. This is A, this is C. This is your reaction VA, right? And what is the moment over here? Is this moment 23.27, which is anti-clockwise. This is 23.27, and this is also anti-clockwise, which is 29.09. And the distance is how much? This distance is how much? This is your, this is how much distance? 4 meter. 4 meter. So this is your VA. This is anti-clockwise. This is your clockwise. VA into 4 equals to all the clockwise moment 20 anti-clockwise 23.27 plus 29.09. ठीक है? So VA equals to आपका कितना हो जाएगा? 23.27 plus 29.09 divided by 4. Let us find how we are getting. So this is 23.27 plus 29.09 divided by 4. We are getting 13.09. 13.09 kilometer. 13.09 kilonewton. And this is your 24 kilonewton. This is your 24 kilonewton. So BV equals to 24.0 minus 13.09. Although this moment is coming, so your BV will be this much, minus 24. So we are getting 10.9. We are getting 10.9. So these are the moments. These are the values we are getting like this. We are getting. So we can draw this shear force diagram or bending moment diagram. We can draw in this way. How we'll draw the BMD, or we can draw. Let us see, this BA and BB is equal to 13.09 and 10.9. Now you can write over here. BA equals to 13.09 upward and BB equals to 10.91 kilometer. And the final moment is this. Final moment is this. This is your 29.09. This is your clockwise 20.36. So, and what about this? This is your anti-clockwise. This is 23.27, and this is your 23.27. This is 23.27. So let us draw the BMD. This is your, what is making this? This is sagging, so you take negative 29.09, right? Let us come to this point. This point. What is happening? This is going in this way, right? This is 23.7, not this way. This is anti-clockwise. This is going like this because this is negative, so this will be also negative. So going like this, so making sagging making इसलिए this will be your 23.27 positive. So your moment will be something like this. This is your positive and this is your negative. And what about the last moment? This is again sagging. So this will be your negative. This value will be in this way. And this value will be 23.27. This will be negative and this will be whole will be positive, that is 23.7. This is your BMD. And what about the shear force diagram? Shear force diagram will be something like this, in this way. This is your, suppose you are taking this way. See, this is 13.09. So this is 13.09. This will go up to here and then droop, and this will go like this. This is your 10.91. This is negative, this is positive, and concept is up and down. This is taken in positive. Shear for convention. This is your SFT. So you can draw the BMD and SFT in this way. This is your, how you will draw this BMD and everything. This is your, you can plot like this. This is your like this. This is your point. This is your negative. This is your positive. This is your negative. This is 23.27. This is your 29.09. And this is your 23.27. 36, sorry, 20.36. This is 20.36. This is this point. So what is, how this behaving? This is behaving hogging, and this is anti-clockwise. This is also anti-clockwise because this is negative. So this will go like this. So this is making sagging. So this is taking positive, and this is making hogging. So this is taking negative, and this is your shear force diagram 13.09. This is your positive, and 10.09 is negative. This is your negative. This is positive. Okay, this is your shear force diagram. So thank you for everything. Thank you very much.